Every robot company looks like it's in a desperate race to build a perfect machine. Different designs, different hardware, different visions. But if you look closely, almost all of them rely on the same underlying technology. Which means this isn't a competition at all. It's a dependency. So if companies like Boston Dynamics and Figure AI aren't really in control, who is? The puppet master is NVIDIA. Now, NVIDIA doesn't build robots. You won't see their name on the side of any humanoids walking through warehouses. But look under the hood of almost any serious robotics company, and you'll find NVIDIA components at the core. More than a dozen of the world's leading robot developers have publicly adopted the NVIDIA Robotics platform. And that number keeps growing. Jensen Huang, NVIDIA CEO, was pretty explicit about their plan. At their annual technology conference, he said every industrial company will become a robotics company. Everything that moves will be a robot. That's not just a prediction, it's a roadmap for NVIDIA's next decade. Here's what makes NVIDIA's position so powerful. They don't just supply one piece of the puzzle, they supply three. Before a robot can do anything useful, it has to be trained. That means running through a task thousands, sometimes millions, of times, learning from trial and error. Processing all of that data requires enormous computing power. And that power almost always comes from NVIDIA's data center GPUs, like the Blackwell, which are the same things powering ChatGPT and other large AI models. So the very first step of making a robot smart, that's NVIDIA. Now, training does make robots smarter, but a lot of these companies aren't just training intelligence from scratch anymore, they're downloading it. NVIDIA's built something called GROOT, or Generalist Robot Intelligence. Think of it like an operating system for robots that give them a level of base intelligence, the same way humans are born with basic reflexes. Instead of every company spending years figuring out how to make a robot grasp an object or respond to a spoken instruction, they download GROOT and build on top of it. The hard foundational math is already done. Which means a lot of these companies with breakthroughs didn't come out of nowhere, they downloaded a head start from NVIDIA. Of course, even GROOT needs to be trained on something. And training robots in the real world is slow, expensive, and robots can break. So the industry uses simulation. Virtual environments where you can run 1,000 robots simultaneously and teach them how to pick things up or walk without risking damage to your expensive prototypes. The dominant platform for this is NVIDIA's Isaac simulation. Think of it like a video game engine built to render a near-perfect replica of the physical world. Properties like gravity, weight, and friction are implemented to make it as close to real life as possible. A robot trained in Isaac simulation learns skills that actually transfer to the real world. In fact, NVIDIA trained their newest version of GROOT in just 36 hours using Isaac Sim. The same process would have taken nearly 3 months if they'd collected that data manually in the real world. But Isaac isn't limited to just NVIDIA products. They're licensing it out. Siemens, one of the world's largest industrial automation companies, uses Isaac Sim to develop and test new robotic skills. Foxconn, the factory that builds your iPhone, is using Isaac Sim to plan and simulate entire factory floors before a single physical robot is deployed. And once again, leading robot developers, including Agility, Boston Dynamics, and Figure AI, have all adopted NVIDIA's Isaac and Omniverse simulation technologies. That means startups aren't the only ones using this technology. These are the biggest names in manufacturing and robotics, and they've all converged on the same simulation platform. Finally, once a robot is trained and leaves simulation, it still needs a physical computer inside it to process what it's seeing in the world. That's NVIDIA's Jetson line. Their latest chip, Jetson Thor, has significantly more AI computing power than its predecessor, while being much more energy efficient. And that's in a package small enough to sit inside of a robot. In fact, this chip is inside most of the new robots you're seeing on YouTube nowadays. So training, simulation, on-device intelligence, 3 layers, 1 supplier. But why is NVIDIA focusing on robots? Well, there's some business context that might explain it. The global robotics market was valued at around $46 billion in 2024, and is projected to get 5 times larger by 2033, and that's just general robotics. The humanoid robot market alone is expected to grow from around $352 million in 2024 to nearly $8 billion by 2034. And NVIDIA isn't just participating in that growth, they are the infrastructure it runs on. Their Jetson product line alone generated roughly $1 billion in annual revenue in 2024, with projections of $3 to $4 billion by 2027 as Isaac developed robots reach mass deployment. And remember, that's just one part of the NVIDIA pipeline. They're also capturing revenue from data center GPU usage during training, from simulation licenses, and now from their foundation models like GROOT. Every step of the robotics production process is a potential revenue stream for them. So what happens when an entire industry is built on one company? At first, it's great. You get efficiency, startups can build faster, investors see results quicker, but you also create a massive single point of failure. If NVIDIA faces supply chain issues, like the chip shortages that paralyzed the auto industry in 2021, or the RAM shortages currently affecting the world, the entire robotics industry stalls. If NVIDIA changes its software licensing, raises prices, or decides to prioritize certain customers over others, every robot company feels it. The pace of robotics innovation isn't just set by the engineers at these startups, it's set by NVIDIA's release cycle. And that's a lot of power for one company. Now, is this a monopoly? Not exactly. There are alternatives. Open source physics simulators like MuJoCo and Bullet exist. Google DeepMind is developing their own robotics research. And some companies are trying to break away from NVIDIA's grasp entirely. The biggest example is Tesla. They've been developing their own chips, simulation tools, training infrastructure, pushing towards a fully vertically integrated system, similar to how Apple designs its own processors. If Tesla succeeds, they could genuinely become NVIDIA independent. Because Tesla understands something most companies don't. If you don't control your pipeline, you don't control your future. But for most startups, there's not much of a choice. Building your own chip takes years and billions of dollars. And if you use NVIDIA's chip, you might as well use their simulation software and their training GPUs too. NVIDIA's tools are already here, thoroughly tested and adopted by the industry. So companies take the path of least resistance. And that path runs through NVIDIA. Jensen Huang recently called this the ChatGPT moment for robotics. And he's probably right. We're heading into a world where robots handle surgery, stock warehouses, and work alongside, or instead of, humans in pretty much every job. The diversity of what's coming will be enormous. But if you look beneath the surface of almost all of them, the training, the simulation, the on-device intelligence, you'll find the same company behind it all. This is why NVIDIA doesn't need to win the robot race. They're not even interested. Because they don't need the best robot or the most robots. No matter who wins, they're already in control. The robotics race might look competitive, but at its core, it's already over.